Everyone. This example that I'm going to do is one that is very common when it comes to recursive programming in any language. Today, we're going to look at how to do it in Python. We're going to look at the Fibonacci sequence. In particular, we're going to look at how do you find the nth term of a Fibonacci sequence. Okay, here I have the function definition for you. It's simply called Fibonacci, and I'm taking in one parameter, n. You know that the Fibonacci sequence is pretty well known, and in that, each term is actually the sum of the previous two. Term 0, similar to a list, the indexing starts at 0, so term 0 is 0. Term 1 is 1. Term 2 would be the sum of the previous two terms. So term 2 would be 0 plus 1, which is 1. Similarly, the next term would be 1 plus 1, which is 2. Term 4 would be 1 plus 2, which is 3. Okay, so on and so forth. So I want you to now pause the video and think about the 5 steps that we talked about. The parameters for the base case, which we know is n. N is the number for which you are, the term for which you are calculating the Fibonacci number. We want to think about the base case, which in this case is either n is 0 or 1. We want to think about the recursive case, which is calling the Fibonacci function on itself with different parameters, in this case, n minus 1 and n minus 2. And then, of course, you want to make sure you have your if. Okay, pause the video and go ahead and try to implement this function. Okay, I'm hoping you tried it and you can actually validate with me. So it's okay if you've had 2 if conditions. In my case, I'm just going to have one if condition that's going to check if n is less than or equal to 1. And in this case, what I'm going to do is I'm going to return n, which means if n is 0, it'll return 0. If n is 1, it'll return 1. Okay, we are asked to assume that n is anyways greater than 0, so there's no need to validate that. Now, you can have an else. The else is optional. I'm just going to put it in this time for clarity of code so you can read it better. So if n is not 0 or 1, what do we need to do? This is our recursive case. Our recursive case basically returns a call to the function, but for one number less than. So we're calling Fibonacci on n minus 1, and we're calling it on n minus 2, and we're adding those two results. Okay, so what happens when I try and do Fibonacci 4? Okay, when I try and do Fibonacci 4, it checks if 4 is less than or equal to 1. Well, it's not. So it goes into the recursive case and it calls Fibonacci 3 and Fibonacci 2. Now, Fibonacci 3, as we know, is again not less than or equal to 1. So it calls Fibonacci 2 and 1, and Fibonacci 2 calls Fibonacci 1 and 0. Okay, so in the end, what we're left with is actually the sum of the previous two terms. Okay, now let's try and call this function. I'm going to call it, since we seem to have done the example with 4, I'm going to call it on 4. Let's run this code. Okay, so you'll see that it returned 3, which is 0, 1, 2, 3, 4, the 4th term in our Fibonacci sequence. Okay, think about the number of lines of code, and this is actually just 3 lines of code. The else was optional. And so it's a really simple piece of code. However, the logic that goes into it is actually complex. So don't worry if you've not got it. Go ahead and look at this video, and I hope that you understand how we recursively call the Fibonacci function. Okay, talk to you soon. Bye.